Hello student, welcome back to my channel Kunal sir at JEE NEET Chemistry World. So now today I am going to discuss another important aspect of organic chemistry which is there in +1 portions, which is under the GOC, General Organic Chemistry, and the heading is Stability of Carbocation. So now whenever organic reaction used to proceed, they used to proceed via several intermediate. Among them, one of the important intermediate of organic reaction is a carbocation. Based on the stability of carbocation, rate of the reactions will be influenced. Their energy profile diagram will be changed. So that's why we need to know the stability of carbocation. So now, cation means positively charged species. Carbocation means like that. If you look at plus charge on carbon, like that we call it as a carbocation. Carbocation, plus charge on a positive charge. So now in organic chemistry, this carbocation is nothing but a one of the important intermediate, because you know very well, suppose I have a reactant is there, and I will add over here substrate. Reactant and substrate, they will form intermediate, and this is intermediate. I am writing like this, intermediate, and then intermediate will form the product. This is the scheme of the reactant, organic reaction scheme, and among that one of the intermediate is carbocation. That means cation of carbon is a carbocation. Positively charged species is called as a cation. Now that carbocation how used to form? Suppose if you look at any of the organic compound, suppose I have a one group like this, CH3 CH2F. This is a ethyl fluoride. Now carbon has a bond with the fluorine. Basic thing already will be there in my molecular formula writing, bond line notations, all those things is there my basic video of organic. Now this carbon has a bond with the fluorine. Now fluorine has a more electronegative element. That's why one bond means 2 electron. If the bond is broken because in a reaction conditions due to, and the 2 electron is going towards the fluorine like this, that means this type of cleavage of the bond is called as a heterolytic cleavage. Heterolytic cleavage means unequal sharing of electron between the bonded atom. That is called as a heterolytic cleavage. And because of this heterolytic cleavage, you will observe what we will get over here. You look at, we will get like this, CH3, CH2 plus, carbon is not getting anything, and the fluorine is getting 2 electron. That's why F minus. Lot of people can come in mind. I can ask you one basic questions. Fluorine is getting 2 electron, but still fluorine is -1. Why? Lot of people will confused, because whenever covalent bond form by sharing of electron only, this is a covalent bond. Fluorine is giving 1 electron, carbon is giving 1 electron. That's why when fluorine is getting 2 electron, already it has 1 electron, only extra 1 electron is getting. That's why fluorine is -1, and carbon is losing only 1 electron. That's why carbon is +1. And whenever in covalent bond between carbon or any other heteroatom, there is a heterolytic cleavage is there, then only you will get a carbocation. Now, if you observe carbocation stability order, very important way. One short I will give the example and I will explain. Then you can get it lot of things. So if you look at this carbocation stability can be explained by electron releasing group, different kind of electron releasing group. And carbocation is carbon is bearing the positive charge, and already you know different types of carbon. Suppose if I am saying CH3 and CH3, now this is my carbocation. This is called 3-degree carbocation. In degrees of carbon, I explain these things in detail. That means whenever this carbocation carbon or designated carbon attached with a 3 carbon, that is called as a 3-degree carbon or tertiary carbon. Because you look at this carbocation carbon attached with a 3 carbon, other 3 carbon, and that's why it's a 3-degree carbon. Then whenever carbocation carbon attached with a 2 different carbon, then it is called as a 2-degree carbon or secondary carbon, 3-degree or tertiary, and 2-degree or this carbon attached with another 2 carbon, that's why 2-degree or secondary carbon. Now if you look at these things, CH3 CH2 plus, this is attached with only 1 carbon, that's why 1-degree carbon, or if there is a single carbon is there, that is also called as a 1-degree. Now in terms of general logic, I can put in presence of electron releasing group, carbocation generally we used to put C plus, carbocation stability will increase. Why? Because carbocation is an electron deficient species. You can look at the carbocation features. If you look at any carbocation, suppose I have like this methyl carbocation, there are 3 bond is there. That means there are hybridization of this one is sp2, 3 sigma bond pair is there. Bond pair of electron will be 6, and here one vacant p orbital will be like that will be there, and on that there will be plus charge. That means if you look at in presence of electron releasing group, carbocation stability will increase. Why? Because it is nothing but a plus charge is there on carbon. This is a electron deficient is like it can act as a Lewis acid. Also it can be like a electrophile. So that's why in presence of electron releasing group, as it is electron deficient, then stability of carbocation will be what? Enhances. Whereas in presence of electron withdrawing group, carbocation stability decreases. Why? Because carbocation already deficient species. If somebody is again withdrawing the electron, that's why carbocation stability will be what? Decreases. Now, if you look at the next slide, you understood 1 degree, 3 degree and all those things. Then I am taking a few example, and in terms of that, hyperconjugation, aromaticity, in terms of all those points I am giving, and I am asking the stability order. Suppose if you look at, I am giving you like this stability order of following carbocation. Stability order of following carbocation. If I am asking like this, stability order of following carbocation. So if you look at very carefully. So now I am taking pH means phenyl group 3 times with that carbocation. pH phenyl group 2 times with that this carbocation. Now this one I am giving structure 1, this one I am giving structure 2. Next one I am giving pH CH2. All are benzylic carbocation, but this is a benzylic 3 degree, benzylic 2 degree, benzylic 1 degree. Next I am giving you like that allylic carbocation. Next I am giving you like this carbocation methyl. This is called tertiary butyl carbocation, 5th one. Next I am giving you Ame, and here ethyl, and here methyl, this carbocation. Both are 3 degree, but alpha hydrogen will be different, 6th one. Now 7th one I am giving you like this CH3 CH, this one. Next one I am giving, this is your 6th, 7th one. Next one I am giving you CH3, CH2. This is nothing but your 8th one. Now next one I am giving you, this is nothing but a 9th one. Next one I am giving you 10th one. Next one I am giving you, this is 11th one. Next one I am giving you phenyl carbocation. This is 12th one. And these are the different carbocation I gave you. Now you look at around 12 carbocation I gave you. Now I am going to explain the stability order of different carbocation. Then you will get a clarity. Now whenever any phenyl ring is there, I hope you know the resonance. Resonance is nothing but a delocalization of a pi electron in a parallel p orbital. Like that, this is a benzylic carbocation, but 1 degree benzylic. 1 degree benzylic. Whenever sp2 carbon attached with a sp3 carbon, but sp2 carbon is a part of a benzene ring, that is called as a benzylic carbon. Now this is a 1 degree benzylic. Now you know very well resonance means like that happening. Next structure will be like this. You will get like this, and next it will be like this. Then you will get resonance means it's a imaginary structures, or to explain the physical and chemical property we are utilizing that one. And this is nothing but this one. Next one is this one. You will get like this, and they are in equilibrium, they are in both direction possible resonance. That's why I am giving the arrow sign. Now we are getting like this. After that, what will happen? You look at this is coming over here, and then we are getting like this. Now you look at, for these you are getting a 5 resonating structure. For benzylic 1 degree you are getting a 5 RS. If resonating structure is more, then dispersion of charge will be more, stability will be more. Now here there are 3 phenyl. For these there is a 15 resonating structures. Here for there will be 2 phenyl group will provide 10 resonating structure. Here they will provide 5 resonating structures. Here they will provide, like this will happen, 2 resonating structures. And with respect to carbocation, also hyperconjugation as well as plus I also will operate in 3 degree carbocation, like the 5th one structures. Hyperconjugation is a sigma pi conjugation or sigma electron of carbon hydrogen bond delocalized with a vacant p orbital. So now with respect to this carbocation, there are 9 alpha hydrogen, and in this structure 3, 3, 6, and here there will be 2, 8 alpha hydrogen. With respect to carbocation, here there are 6 alpha hydrogen with respect to carbocation, and here there are 3 alpha hydrogen. Here there is no alpha hydrogen. Here carbocation is there on generated on sp2 carbon. Here sp carbon, and phenyl ring also is generated on sp2 carbon. This is the picture. Now if you look at very carefully, first of all aromaticity will be greater than equivalent resonance or equal resonance as per the electronic effect order, and then equivalent resonance is greater than resonance, normal resonance, and the resonance is greater than hyperconjugation. Hyperconjugation is greater than inductive. So these are the electronic effect order. Whenever more than one effect is operating, then suppose you look at resonance operating, hyperconjugation, then which effect will be dominant? Resonance. Suppose if you look at minus R also dominating, plus I also dominating, then who will be minus R also working and plus I also working, then who will be dominating? Minus R. Like aromaticity is present as well as inductive effect is present. Who will be dominating? Aromaticity. Like that idea. So now if you look at over here, there is 15 resonating structure, maximum dispersion of charge will be there. That's why the stability order will be, if you look at, first one will be greater than, that means 3 degree benzylic, after that 2 degree benzylic, after that as per logic you will say, sir, it's a 5 resonating structure, it's a 2 resonating structure. 1 degree benzylic will be more stable. But now compared to these two, tertiary butyl cation, the fifth structure, Roman fifth structure, is more stable. Why? Here hyperconjugation effect is there of 9 alpha hydrogen, as well as 3-methyl group is providing the plus I. This is also providing the plus I. This is also providing the plus I. That means 9 alpha hydrogen providing you hyperconjugation effect, and 3-methyl group is providing 3 plus I to stabilize this carbocation. And this effect is slightly able to overcome the 5 resonating structure of 1 degree benzylic carbocation. That's why tertiary butyl carbocation is more stable than 1 degree benzylic carbocation. So that's why this exceptional point you have to remember. 1 is more stable than 2, 2 is more stable than 5. And now after that, if you look at benzylic will be more stable. After 5, benzylic is more stable. After that, 3 degree, that means 6th one also 3 degree, but 8 alpha hydrogen. Always remember, compared to 1 degree benzylic, 3 degree carbocation, condition should be 9 alpha hydrogen, then only, and 3 methyl group is giving plus I, that means tertiary butyl carbocation will be the most stable. So that's why after 5 you will see the stable will be nothing but a third one, and after third one you will get here resonance effect is there. So that's why this will be the fourth one, allylic carbocation, and after that you will be sixth one. You look at sixth one is a 3 degree carbocation. After that, eighth one, seventh one. After 7, eighth one. After that, ninth one. And now you look at after ninth one, sp2 carbon positive charge will be more stable than sp carbon, and that's why it will be 10th one. And in phenyl carbocation on sp2 carbon positive charge, that will be more stable than the positive charge on sp. That's why 12th one will be more stable. 12th one will be more stable than 11th one. So that will be your stability order. Always remember. Only exceptional point, tertiary butyl carbocation will be more stable than benzylic. That point you have to 1 degree benzylic resinous. That 5 resonating structure will overcome by the 3 methyl group plus I, as well as 9 alpha hydrogen hyperconjugation. So now let us look at another few example, and then I will stop over there. If I take like this, suppose I have a all places benzylic carbocation. Now here I am giving a nitro group, and here I am giving a all place benzylic carbocation. Here I am giving a OMe group, and here I am giving you, if you look at another CH3. Now here I am giving you, CH2 plus, and here I am giving you OH, and here I am giving you, CH2 plus, and here CH3. Now here I am giving you only benzene. This many things I am providing you. All are benzylic carbocation. Now here the number I am giving 1, 2, 3, and then 4, and then 5, and then 6. Now you look at, if I compare the stability of this carbocation, all are benzylic. With that different, all are benzylic, benzene ring is there. With that different group attached, only you need to identify what effect is there, and that point you have to remember. So what is that point? That electron releasing group always will increase the stability of carbocation. All cases benzene ring is providing the plus R to the CH2 plus. With that additional what group attached with the benzene ring, that will play the key role. And now if you look at the nitro will exert minus R as well as minus I, but minus R will be greater than inductive, because order is aromaticity is greater than, equivalent resonance is greater than, resonance is greater than, hyperconjugation is greater than inductive. So now here this group, because this will withdraw like this way, you know very well, nitro group electron will be like this. If you open up the structure, one side this oxygen and this will become like this. Now here if you look at, this group will provide the plus R like this. If you look at this group will, that means here plus R is greater than minus R. Now this group will provide the hyperconjugation. Hyperconjugation is greater than plus I. Meta position means only with respect to benzylic carbocation means only minus I. Meta positions only minus I only. No resonance, no hyperconjugation. So that's why here minus I only, here plus I only. And here benzene ring is providing only plus R, which is available for all cases. Now maximum releasing effect observed for the para position OMe with respect to the benzylic carbocation. That's why my stability order is stability order of the carbocation, stability order of carbocation, stability order of carbocation. If you look at that, 2 is greater than, if you look at 2 will be greater than. After that, where are the other releasing effect is there? Here one releasing, here one releasing. Here hyperconjugation, here plus I. Hyperconjugation effect stronger than plus I. So that's why 2 is greater than 3. 3 is greater than 5. Now, in 4R structure 1, there is a withdrawing effect. Compared to that, benzene ring, there is no releasing, no withdrawing. That one will be stable. Now, here in between structure, if you look at 4 and structure 1, in between structure 4 and structure 1, both are in withdrawing effect. But here structure 1 withdraw via minus R, but structure 4 is withdraw via minus I. Structure 1 is withdraw via minus R, structure 4 is withdraw via minus I. Minus R withdraw will be more. That's why that will be least stable. So then that's why fourth one will be more stable compared to the first one. That is why the stability order. Generally, if you look at, everybody know this logic. If you have tertiary butyl carbocation like this, if you have isopropyl carbocation, if you have that ethyl carbocation, and if you have methyl carbocation, this is already 3 degree, this is already 2 degree, this is 1 degree, this is 1 degree methyl. Generally, you know, in case of just last slide I explained, 3 degree carbocation is more stable than 2 degree, 2 degree is more stable than 1 degree due to more hyperconjugative structure as well as plus I. So that's why overall stability, how you will remember, whenever the different degree of carbocation come to the picture, stability of carbocation, the order will be 321. 3 degree is greater than, 2 degree is greater than 1 degree. Always remember. And among the 1 degree, that the methyl 1 degree will be the least stable. Suppose if I give the 1, 2, 3, 4. Why methyl 1 degree least stable? Because at least ethyl carbocation, that one methyl group is giving hyperconjugation as well as plus I. So that's why methyl carbocation always will be the least stable. How you one shot remember? Stability order of carbocation is 321, whereas carbanion is 123. So that's why that way you will remember all those things. Is it clear to everybody? I hope I able to give you clarity to each and everybody regarding the stability of carbocation. And to get more and more this type of clarity on different part of chemistry, come and have a look my channel and get the clarity and be confident for upcoming your JEE, NEET, all types of exam. Thank you very much. Thank you all. See you in the next video.